In this video, we're going to learn the concept of a one-sided limit or one-sided limits. So let's go with the definition. Alright, so this definition does have two parts, so it is a little long because we first have to start about right-hand limits and left-hand limits, but they're both essentially the same except for a couple of words. In parentheses, I'm going to go ahead and put here informal. Okay. So again, I'm just giving you the basic definition of a right-hand and left-hand limit. When you guys get to college, and if you take Calc 1 again, there's another definition for a right-handed and left-handed limit that is a little bit more complicated than this, but anyways, this definition works. If f of x approaches arbitrarily close to L, as x approaches A from the positive side, of A, then we say that f has a right-hand limit, L at A, and we write, and then we say the following. We'll have our limit, and then we're going to have as x approaches A, and then we put a little plus up here. And so what that plus means is we're coming from only the positive side of A. So if you remember, when we did limits before, we came from both sides to see what the limit was. Now we're only coming from the positive side. And of course, if you're coming from the positive side, that's the right side of it. So that's why we call this a right-hand limit. So we're coming from the positive side. F of x equals L. Right, so we're going to look at some examples here soon, but the whole idea of a one-sided limit is it's even kind of in the title. Instead of coming from both sides of A, or whatever the number is we're calling only from the right-hand side or the left-hand side and seeing what happens. Alright, so let's do the other definition. It basically is the same as this one. It's just now we're coming from the left. If f of x approaches arbitrarily close to, we'll use m this time, m as x approaches A from the negative side, of A, then we say that f has a left-hand limit has a left-hand limit m at A, and we write, so this time we're going to write the limit as x approaches a from the negative side. And so that negative means we're coming from the left-hand side of f of x equals m. And so there is our left-hand limit. So let's look at a couple of examples. Or an example. So here's some function, f of x, made up function. Alright. And we have a circle here. Go this way. Circle here. This way. Dot down there. Alright, so here's our function. And so let's say we were asked, what is the limit as x approaches 2 from the negative side of f of x? So this is our left-hand limit. What is happening as we approach 2 from the left-hand side? So instead of us having to worry about, well, what's happening as we're approaching both sides, with one-sided limits, we only have to worry about one side. So we're coming along, we're coming from the left-hand side, and we say, oh, we're approaching 1. So there's our answer, 1. And we have, what is the limit as x approaches 2 from the positive side of f of x? So again, we're coming from the right-hand side, and as we keep on approaching 2, where does our function go? And this time it's going to 0. Now, we can ask, what is the limit as x approaches 2 of f of x? Well, now that we have the one-sided limits, it's easy to figure out what is the limit, because if from the left we're going to 1, and from the right we're going to 0, that means we're not going the same number on both sides. So in this case, it does not exist. And then we can also ask, what is f of 2? And in this case, f of 2 is just negative 2. Because remember, it doesn't matter what's happening at the value of 2. We only care about what's happening as we get arbitrarily close to 2. Okay, so one-sided limits, once you understand what a limit is, one-sided limits aren't too challenging to understand because we're just now picking one side or the other. Now, this is a good situation to look at our next theorem. And this next theorem has to do with, sometimes you're asked, well, does the limit exist, yes or no? And a good way to look at it is this idea that, well, do we have a right-sided limit? Do we have a left-sided limit? And are these limits equal? So notice that for the limit to be equal, for the limit as x approaches 2 of f of x to actually exist, you have to have a right-sided limit, you have to have a left-sided limit, and those two limits have to be the same. And so that is our next theorem. So let's write that out. This theorem doesn't have a name, it's just called. So our theorem states a function f of x has a limit as x approaches c if and only if it has left hand and right hand limits there, and these one-sided limits are equal. Alright, so there's that if and only if statement. That's the biconditional statement. So, well, first let's get a little diagram of what's going on here. So what this is saying is the limit as x approaches c of f of x equals L. Now, if this is going to be true, if the limit as x approaches c of f of x equals L, if that is true, that can only be true if the following two things are true. First, the limit as x approaches c from the left-hand side of f of x must be equal to L, and, let's see if we can fit it in here, the limit as x approaches c from the right-hand side of f of x must equal L. All right. And I mean, this isn't a super challenging theorem, and it makes sense. And all it's saying is, well, in order for a limit to exist, the left-hand limit has to exist, the right-hand limit has to exist, and they both have to be the same value. Hence why this one does not exist. This limit doesn't exist because these two limits, they exist, but they're not the same value.